Today we learned the first consequence using the fundamental theorem of similarity. We were given a coordinate plane and we were given point O at the origin and point A. And this is the question that they are asking us. In the diagram below we are given center O and ray OA. Point A is being dilated by a scale factor. R is equal to 5/12. So again, I would highlight that, circle it, box it in. Use what you know about the fundamental theorem of similarity, also known as FTS, to find the location of point A prime. So right away, what I should notice is my scale factor is less than 1, so I know my figure or my image will be made smaller. So let's just see what our steps are. Take a moment to write these down if you need to. First step is to draw a point straight down from point A directly onto the x-axis. Since it is a different point, we're going to label that point B. Connect points A and B to create line segment AB. Now, we're going to use our center O and we're going to construct a horizontal line from O to B, and we're going to use our formula to find B prime. That is working using the horizontal line. When I want to work with the vertical line, I'm going to use line segment AB, and I'm going to then use our formula to find where is A prime, B prime located, and my ending result is going to be, I use the horizontal and the vertical point to get the location of A prime. So let's see how this is done. Here's my question. So here in the diagram, I am given point A and point O. First thing I want to write down is I'm going to be working with that horizontal line first. So the first thing I'm going to do is from point A, I'm going to drop down the line, and on the x-axis, call it B. Here's my x-axis, here's my y-axis. Now, if I'm working with the horizontal line, I'm going to be working with OB. So the formula that I'm going to be using. The length of OB prime is equal to the scale factor times the length of OB. Let us fill in the information that I know. I do know my scale factor is 5/12. That they gave me in the problem. I do know the length of segment OB. I can actually count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It is 12 units in length. So I'm going to put it as 12/1. So now my formula is telling me the length of OB prime is equal to 5/12 times 12/1. What I'm able to do here is I can simplify by multiplying these two fractions together, and the two 12s can simplify to 1. So now I get the length of OB prime is going to equal 5/1, or 5 units. That is my horizontal distance. So now what I'm able to do is from the point O, I can now count out 5 units in length, and that is going to be the location now for B prime. So my horizontal is complete. Let us now take a look at what I do for vertical. So I'm going to now write out the word vertical, and I'm going to think, what line segments do I use? So for vertical, I'm going to be looking at AB, and I'm going to be finding the length of A prime, B prime. So I'm going to be looking for the length of A prime, B prime, and that is equal to the scale factor times the length of line segment AB. So let us fill in the information that I know. I know my scale factor is 5/12. I do not know the length of A prime, B prime, but I do know that AB is 1, 2, 3, 4, 5, 6, 7, 8 units in length. And again, I'm going to be looking at my two sets of fractions, and I can simplify. The 8 and the 12 is divisible by 4. So when I work my fraction through, I'm going to get 10/3 is equal to A prime, B prime. Okay, well that's an ugly looking number, but I can change that into a mixed number. So I know that the length of A prime, B prime is going to equal 3 1/3 units. Again, I'm converting it into a mixed number. So what that is telling me, when I look at the B prime, I have to now go 3 1/3 units up. 1, 2, 3, and a third. So A prime does work out to be exactly on that line from OA, and that agrees to the formula that I have. So I found the vertical and the horizontal distance. Now where is point A located? Remember, A prime. Remember my coordinate is always x comma y. So A prime here is going to be equal to 5 comma 3 1/3, and that is how I get the exact location for A prime using my fundamental theorem of similarity.